Anyway, good morning or good afternoon, depending where you're at. And thank you for attending this session on unlocking rapid data recovery and minimizing downtime. I'm John Crossno. I'm a product management director at Rocket Software, and the session number is 1J. Don't forget to do a session eval at the end. Enter 1J or use the QR code. Go forwards. So what is business resilience, right? And the definition, a good definition is it's an organization's ability to adapt when disruptions occur and maintain business operations while keeping staff, data, and the reputation of your company safe. And core to maintaining business resilience is the health of your system. And when I say health of your system, I'm talking about your catalogs, if you have HSM, your HSM environment, all of that. And maintaining those healthy environments are really core to maintaining business resilience or keeping your system healthy. Storage, data storage, and system performance are critical as well to system health. So maintaining, your storage subsystems, your performance of your system and everything, monitoring all of this, getting analysis, doing, of course, out of all of that comes capacity planning, are also a part of resilience. We all know that the mainframe is critical to business resilience, right? Preaching to the choir here. And Z systems generate, 75% of all enterprise data. Now, this number can be disputed, right? I've seen it anywhere from 70% to 80%. I think at the end of the day, a lot of it's guesswork, but what isn't guesswork are the number of companies, right? The size of the organizations worldwide that use mainframes. You can read the rest of those stats. What I always like to point out here is the percentage of all the credit card transactions that go through a mainframe somewhere. And what's also interesting is the daily transaction volume versus Google, right? So the mainframe processes more transactions than Google does, right? Google search. So let's go back in time, and some of you may have some long memories, and some of you may be newer to the industry and are looking at this and saying, "What the heck is that?" Yes, those are tape drives, and we're going back to the 60s, to the 70s, and even into the 80s. That was the old way of doing things. Volumes were backed up to tape. Application backups were made to tape, right? Historically, that meant retrieving everything from tape. And, tape systems got smarter. It was nice when they were feeding themselves. You put a reel on and it fed itself into the system. And they evolved. But that was how things were done for a long time. And in some organizations, they still use tape. But tapes were involved in that disaster recovery process too. So you would also, create your backups and you would send some of those backups off-site for your DR purposes. And so you put them on a truck, and that truck would then drive those tapes to some off-site location that was safe and protected. But then things happen, and you have a disaster. And so then you have to have somebody, or the company you sent them to, they have to ship those tapes back to your DR site, right? Your location where you were going to perform your recovery and continue operations while that smoking hole in the ground was rebuilt for you. And that was really, the way that DR was done, right? You had a remote site and those tapes, and it took time to get those tapes from wherever they were stored back to your DR site. So what does that mean? It means downtime. You were out of business for a bit. but data is growing, right? The really interesting stat here, and it's a few years old now, but in 2019, 90% of all data created was created in those previous 2 years to that. So if you think about, the advent of data creation, up until then, right, 90% of it was just in those 2 years. I haven't seen a more recent stat for that to replace it, but I imagine that the growth of data, right? If you look at the other stat there of the number of zettabytes worldwide, expected at 175 zettabytes by next year now. That probably that number is compounding. And why are people keeping data? Well, because they can. Analytics is driving a lot of it. It's we got to keep the data because we don't know what we're going to need. We might want it for something, right? And analytics is one of those use cases that you want to keep data for because you don't know what you might want to feed into analytics, what you might want to, use that against. And now with AI coming in, generative AI and others, feeding that data into those data models, helps improve those models as well. So you want to keep that data. And I'm sure the storage vendors don't mind, all that data growth. That's helpful for them. However, if you look at all the data that's created, there's another stat I didn't put in here, but all the data that's created, there is not enough storage in the world today to store all of that data. So that means that a lot of that data is being thrown out. Now, a lot of that data is probably not very useful, or it has a very short, lifespan, maybe in seconds or minutes, and it's not, doesn't need to be kept. But yeah, that was an interesting stat when I saw that. But the old way of doing things evolved. And I'm not trying to draw a relationship here between when virtual tape library systems came into being around the time that the Z10 was out. It was just a convenient image that I grabbed. I think the disk library management systems, or the virtual tape library systems rather, were out already before the Z10. But the idea is that it did evolve, and we started moving away from physical tape into virtual tape. And virtual tape, of course, is backed by disk. And so, those came into being, and, the performance was great. The speed at which you could perform backups increased. The performance gains you got for recovering data, right? Doing restores of that data were that much faster. You didn't have to wait for a tape mount, and in between here, of course, were the robotic systems and everything. But you didn't have to wait for the tape mount or the cartridge mount, and you didn't have to wait for, those to be read. Today's tape systems or cartridge systems are pretty fast, but are you going to get as fast as disk? Probably not. So those came into being and things evolved. The other evolution that was taking place was replication, right? And so disaster recovery kind of became more business continuity. And technologies such as SRDF, mirror technologies like Metro and Global Mirror. So Dell and IBM leading in here. I don't have any Hitachi examples here, but Hitachi has some similar technologies. So these technologies came about and really drove us towards business continuity, right? Replicating data and business continuity, so that if a system failed, or if a storage system failed, you could easily fail over to where you were being replicated to. And of course, virtual tape systems were also starting to be replicated. So if we look at that, this is what an environment could look like. I'm using a Dell example here. There's the mainframe on the left, and then you have your your DASD storage and your virtual tape systems. And we started seeing, of course, the DASD getting replicated, and then the virtual tape libraries also being replicated. So now you're replicating not just maybe to another site that's local, but maybe you're replicating to what would be your DR site. So that image earlier, that graphic of that truck driving to a storage location and then driving back to your DR site, that kind of goes away, right? It's replaced by by the replication that you can perform between systems. And when bad things happen, you fail over to one of your other sites and continue on your merry way. Is there going to be some data loss? Well, maybe. It depends. Depends on where that remote system is and the technology used to get the data there. But then tape systems were also being replicated. So, you may have a tape system that's being replicated, and you can perform a recovery off of tape from a remote site too if you needed to. The idea here, of course, is that these are, you don't have to ship your tapes, physical tapes, off anywhere, right? Because it's all being handled by these subsystems. But yes, let's wait. There is more. Right? There's one way of doing things, and of course, there are other ways of doing things. And the replication is not a total replacement to backing up your data, right? Whether it's physical, you're replicating your DASD so that you can fail over, or replicating tapes, virtual tapes. That's still not a total replacement, right? Because what are you going to do if you're going to recover? Are you recovering full volumes at a time? How are you performing that recovery? So then came along Z data protection, or data protection for Z, or Z. Maybe it should have been DPZ. I don't know, but this was really a game changer. And Dell had this first, and IBM has it, and Hitachi has it as well now. But the whole idea here was we need to protect our backups, right? So that we can quickly access them and protect them against things like ransomware, right? Malware, if you will, human error, sabotage, right? The insider threat. You have to protect these backups so that you can get them back quickly, right? But you want to get them back to a point in time. You don't want to go back to, say, the backup that you made 6 hours ago or 12 hours ago or last night, right? Or maybe not even at the beginning of a batch job. Maybe you want to have some recovery earlier, right? You want to be able to recover to maybe 5 or 10 minutes ago, right? So these snapshots that are being made really allow that, right? And so that you can do a snapshot, say every 5 or 10 minutes, and now you have a virtual image of a volume that you can then restore, right? Granted, there are limits, and storage can be a limiting factor. But essentially, this gives you sort of a time machine for the mainframe. Do you want to go back 5 minutes? Do you want to go back 10 minutes? Do you want to go back 30 minutes, right? Where is that backup, that copy that you made? What's the best one for you to use, right? And it really depends on what the problem was that's causing you to want to go get one of those snapshots and perform that recovery. So let's look at recovery needs. You want to have a centralized visibility to all of your backups, right? And perform an easy recovery. And by all backups, I mean whether they're physical tape, virtual tape, or even the ZDP images, right? The snapshots that are made. You want to easily find and restore or rename, right? Those individual data sets. When you recover a data set, do you want to lay it over the top of the existing one, or do you want to rename it as part of that process so that you can compare, right? And make sure it's the one you want before you put it into production, if you will. And then there are technologies for backing up DB2 and IMS. right? Fast replication technologies that you want to use. And what's really important out of this is that you're complying with regulatory, with the regulations. And so there are reports that need to come out to say, hey, we did backups. We backed everything up. This is when it was backed up and all of that. And there are various regulations, in different regions. In the States, we have SOX. In Europe, it's going to be something else. And the UK probably has their own as well. But you want to be in compliance, right? And show that you've made backups and that you have that level of resilience at least. But what is a backup if you can't restore it, right? There's no regulation about testing your restore except for your DR processes perhaps, but they always want to make sure you're backed up. So you needed something like a data recovery manager. And a data recovery manager can, collect information from the systems, from jobs that are running, from backups that are being made, and store that information in a repository, and tie some of those data sets together, right, from an application. So now you get an application view of data sets, and you can select the individual data sets that you want to recover. And those data sets could be located on, like I said earlier, for physical or virtual tape, or maybe they're in a snapshot, right, made by the technology we were just looking at from Dell, from ZDP. And so you have a choice on when you want to recover that, but the choice is only good if you have a central view of where it is. Perhaps the best backup for you is not in a snapshot from ZDP. Right? Perhaps it is on tape, right, or virtual tape, physical tape from the day before. It really just depends on the situation. So you want to incorporate space efficient snaps, right, for your data copies. These snapshots are full volume snapshots, but really they're not the whole volume every time. Right? It's looking at tracks, right? At information that has changed. And it's really only capturing the data that's changed every time, but it's putting it together. So your view of it is the view of an entire volume, right? And the really important piece of this is they're immutable, right? They're protected. They can't easily be accessed, right? They're not accessible to ZOS, not directly, because they were made by the storage array and they're protected by the storage array. And then there are other things involved there, the expirations, they roll off, of course. It can only maintain 1,024 snapshots per source, so they do roll off. But and that 1,024, is that a day's worth? Is it 2 days worth? That really all depends on how frequent you're creating those snapshots. Question? Okay. Yep. Feel free anytime. Question, comment. Just unmute yourself and happy to entertain that question. So you're going to use a lot of snapshots to protect your data, right? Say you're doing them every 10 minutes. And so you're replicating the data across to another system, to another array, and then you're creating snapshots, right? Every 5 or 10 minutes, right? And these can be these are basically or almost air gapped, right? They're in a virtual vault. And the idea is that they're protected from ZOS access, right? So in the event of, say, ransomware, and before you say, oh, ransomware on the mainframe? No way. Yes way. So, you want to, protect against those things. So what happens if you get ransomware, right? Something happens on your ZOS system, your production system, and all the data gets encrypted. Well, you could pay some money and get a key, or you could recover the volumes that are closest to when the ransomware occurred, right? And you may have to go back a little bit further because you need to investigate what caused the ransomware. Was it a code change? Was it somebody in the system, right? What caused it? So you want to get back before that point in time. But the idea is that it's a point in time that you can go back to. But this really, shortens your data loss, right? It minimizes data loss. It gives you a better recovery point objective and a better recovery time objective as well. So you got to discover the corruption and go back before the corruption so that it doesn't occur again. On the note of ransomware, the idea of ransomware, of course, is that it encrypts all of your data, and then whoever or whatever is doing it, and then they hold the key, right? And the key, of course, you need to decrypt everything. What is pervasive encryption? All your data is encrypted, but who has the key? Well, you do. What happens if that key vault gets encrypted, where all your keys are? In a second, you've lost access to all of your data, because not only was it encrypted, the keys to decrypt it, right, for normal production is itself encrypted by someone else. And now you don't have access to either of it or any of it. So that's why it's really important to make sure that those keys are really protected, and privileged users don't necessarily have access to it all the time, right? Really protecting those keys, because pervasive encryption is kind of the ultimate ransomware. You lose your keys, you've lost access, you lost your data. So, you may have to go back to the most current good copy, right, between all of the snapshots, and then perform your recovery from there. But wait, that's only a partial solution, right? The storage hardware vendors, and it's, all of them. It's Dell, it's IBM, it's Hitachi. They don't really provide a good, a real granular solution to recovering individual data sets. It's great that you can create these snapshots, these full volume snapshots. It's great you can recover data right at the volume level. You can get back a whole volume of data. But what if you've had some corruption and you just want some of it? You don't want all of it, right? And that level of granularity can mean different things to different people. If we look at the top, maybe that's a volume, right? And then you have layers of granularity underneath that, down into data sets, maybe down into individual records, of course. It really, again, it's what level of granularity do you need? Looking at it from a satellite perspective, right? You've used Google Maps satellite view, for example, and you can go from a high level and drill down into and look at somebody's front yard or their driveway, right, and see what car was parked there on the day that picture was taken. So in this case, granularity really means, for our purposes here, is taking those full volume backups, right, and recovering individual data sets out of that, whether they're data sets, right, that contain it's VSAM data, could be load libraries that you're recovering, right, but data sets, and so that way you're not having to have the space to necessarily recover and save an entire volume, right, and fish through all these volumes that you're looking for. You're really wanting to get down to that level of granularity of individual data sets. So that's called surgical recovery, right? You're surgically recovering data sets out of these full volume snapshots, right? These full volume backups, because you don't want the whole volume. You just want those individual data sets. So you want to recover identified point-in-time data sets, right, from across DASD volumes contained in my example in these Dell ZDP snapsets, right? And just because a data set is on volume A today, right now, doesn't mean it was on that volume, maybe a couple hours ago, right? Or it could be moved. And so, but it depends on the point in time that you're doing your recovery from. But by recovering individual data sets, right, and automating that, you're going to reduce the time and effort required to do it manually, right? If you do it manually, you have to link a volume or recover a volume, as the case may be, depending on the technology. And is this the volume I wanted? Well, let me go look at my master catalog and let me figure out, which data set, look at all the catalogs, figure out is the data set I want, right? Which volume is it on, and recover that volume. So you might wind up recovering, a lot of volumes to see if what you're looking for is on there. But automating that reduces that time and effort. And because you're reducing that time and effort, right, you're going to reduce your application downtime due to data loss. It could be a DB2 object that's corrupted. It could be just an application VSAM data set that's corrupted. And whether it was intentional or accidental is at this point irrelevant. You need to get it back. And because these are point in time, you can go back, 5 minutes, 10 minutes, whatever the frequency of those snapshots are. and that really lowers your recovery point objective, right? Compared to traditional backups. The traditional backup means, geez, do I have to go back to last night's backups? Do I have to go back to some, the beginning of some other batch job and get the backup from there? But what about all the steps that were performed and all the data that was processed throughout that cycle? Perhaps I want to catch it in between a couple of steps, right? What was that timestamp? Where do I need to recover to? So really the idea is that you can, lower your RPO as compared to the other traditional backups. So I talked about a data recovery manager a few minutes ago, and providing that centralized backup, right? That centralized view of everything, helping you to identify the data sets that you want to recover, right? And helping drive that recovery. And so if you think in terms of ZDP, right, you want to have some data recovery for Dell ZDP in this example. You want to have a view of all those snapshots, right? When did they occur, right? What point in time do I want to go back to? And that's where you want to go back to surgically recover those data sets. And in the end, lower your RPO and lower your your recovery time objective as well. DB2 is really important here, and you need products such as IBM's DB2 Recovery Expert because it understands what's needed for a VSAM or for a DB2 object to recover it to a particular point in time, and so it knows what those data sets are. And then it says, hey, give me all of these data sets back, right, from a particular point in time. And then I will recover that object using DB2 logs, right, and roll forward to the real point in time that I want to get that object back. What about operational resilience, right? Stuff happens, right? Data sets can be accidentally deleted. An application could cause corruption. An application could, cause a DB2 object to be damaged. And then, of course, there's miscellaneous hardware or software failures that can occur, right? All of this can, in theory, cause data corruption, right? Cause problems, and it may not be immediately visible. But these are all areas that can happen. I mean, stuff happens, right? We work in technology, and technology is not always perfect. And then there's ransomware, right? Um, when you talk about encryption of data, right? The original intent of the technology was to protect it. Well, yeah, it's protected all right. And ransomware protects it for someone else, right? Against yourself. So what do we do? Well, there are different levels of ransomware, right? And some of it depends on the level of privilege or the access that the privileged user has. Do they have access to all of the data? Do they have access only to the data for an application? And are they encrypting potentially just data for that application as opposed to entire volumes of data? But you need the ability to recover individual data sets regardless, and recover close to that point of failure, right? You want to lower that RPO. How long will that take, right? Your recovery time objective is critical. The savings in doing it, in automating it, isn't in the time it takes to recover it manually versus automating it. It's your application that's impacted. And if you have corrupted data, if you have a data set that was deleted, right, being able to recover it quickly means that application can be back in production quicker. And that's where the real savings is. So you want to be able to surgically recover data sets from Dell ZDP in my example. Perhaps it's IBM safeguarded copy, perhaps it's Hitachi's Fortress. But you want to be able to surgically recover those data sets. And so using my data recovery manager example, right? Traditionally, you can recover, you have a view of your virtual or physical tape environment, and you can perform your traditional recovery there. But then we have the snapshots that are made by ZDP. And in this example, maybe they're created every 6 hours, right? And so every 6 hours is still going to be better. So going back 6 hours is still going to be better than going to yesterday's backup, for example. So you want to drive that recovery process by identifying the data sets that you need to recover, right? And then performing that recovery. You need to find the volumes containing the data sets that you want, and you want to link those snapshots so that you can see what's see what's in them and recover the individual data sets out of it. And you want to recatalog those data sets that you've recovered so that they're now usable again. Are you recovering them? Are you cataloging them rather using the same name as they were originally? Probably not. You want to rename them, right? Either change the high-level qualifier or something so that you can have them side by side, right? Your recovered data set along with the one that was damaged, and if it was deleted, well, it's gone. But you want to make sure you don't just overlay them right away. So then you have access to those recovered data sets, and you can do what you need to do with them. As I was talking earlier about DB2 Recovery Expert, it can kind of do the same thing. It understands DB2 objects, and so it knows which VSAM data sets are required to be recovered. And then the rest of the process is the same up until it can then use those recovered VSAM data sets and the DB2 logs to perform a roll forward recovery on those DB2 objects. So from a remote site standpoint, you're probably replicating data from a production system to a recovery system, and you're likely using asynchronous replication for that. And the reason for that is when you're taking those snapshots, your I/O is being held up for the time it takes to perform those snapshots, but you don't want to impact your production. And so you're doing an asynchronous replication, so your changes just queue up while you're performing the snapshots, and then everything catches up again. So in this example, we have snapshots taken every 10 minutes. So we have three snapshots here, right, going back 30 minutes. And then we can drive the same recovery process again to find the data sets, for the timestamp that you're looking for, and recover those data sets so that you have now catalog data sets that you can then restore or use in whatever way you need to use them. You still want to get those data sets back to your production system, and there are different ways to do that. You can set up an SRDF link to bring those data sets back. You could, if there are multiple data sets, you could use something like DFDSS to bundle them up, right, and use NDM or FTP to bring them back. There are different ways to get those data sets back to the production system, which is probably where you want them. DB2 is going to look very similar, right? It's the same process. It's going to drive the recovery of the data sets that are needed for an object, and then the rest of the process is all the same. So that was the end of that rapid recovery of data sets from ZDP. I didn't see any questions. Normally this would have taken a little bit longer, with a little more interaction, but are there any questions at this point from anybody? All right, well, I thank you for your time. Please don't forget to provide some session feedback and complete the survey there. Again, the session code is 1J, or you can use the QR code there.
Cheers, John. Thank you very much.